physics knowledge videos, and this one we're going to talk about energy. So we're going to talk about the basics of energy. Most of this is true for everyone. Some of it will only apply to my honors classes. Sorry guys, you have to do more, thus the term honors. So when we talk about energy, we are talking about the ability to do work. Okay? And you're like, well, what's work? Well, we'll get to that in a second. But energy is the ability to do work. And so we're also going to have to define what work is. And work is, basically how you transfer energy. So it's a circle of I define you, you define me. It's like a good relationship, really. So when we do energy, we're going to be look at different types of energy. And there are many types of energy. This is not the inclusive or all-inclusive list, but these are the types that we're going to deal with in our physics class. All right. So first of all, we have kinetic, which is the energy of motion. We had an entire unit on kinematics. Kinematics just kind of means motion, moving. And we use the symbol E sub k. All right. We also have what's called gravitational potential energy. Potential energy. And this is when you have the ability to fall. Okay, so you have gravity, and gravity could do something. All right. So I often think of it as the ability I could fall. So that's the question I ask myself, could the object fall? Now, obviously, if you're standing on the surface of the earth, then you're like, well, I can't fall. Well, what if I dug a hole next to you and you stood next and you were to step into that hole? Then you could fall down. So quite frankly, this gravitational potential energy always needs to be relayed to something, and it has the symbol of Eg. But it has to be related to something. So you have to say, I'm calling this the ground. I'm calling this the ground and I can't fall. Because technically, you could fall and I could be like, well, what if I dug a deeper hole? Okay, well, they fall in that hole. What if I dug a deeper hole? You keep falling. So technically, the only place on Earth where you actually have zero gravitational potential energy is the center of the Earth. But we are going to show and talk about how we can arbitrarily choose where we're going to call zero. And then you can get positives and negatives if you really want to get into that. But that's going to be one that's going to show up a lot. All right. Now, this is for my honors class only, but I did not want to make two videos because I am efficient. So this is only for my honors class, and this would be elastic potential energy. And this is when something's being stretched or compressed. All right. So this is the energy stored. That's what potential means. It's stored. It could be released. When something is stretched or compressed. Best example of this is a spring. You can stretch a spring and it wants to bounce back to where it used to be. You can compress a spring and it wants to bounce back to where it used to be. Rubber band is a one-way thing. You can crush rubber band, it really doesn't care, but you stretch it, it's like, no, I want to go back to where it used to be. All right. So this we have EEL for elastic. All right. And then the last thing which I mentioned here is energy is the ability to do work. Well, work is our other thing, and this is the ability to transfer energy between systems. All right, so work is me saying, oh, I'll give you energy or I'll give this thing energy and stuff like that. how much work did you do? Well, I lifted this dumbbell a lot of times, so I gave it a lot of energy. Unfortunately, I kept dropping it, so I kept losing the energy. But still, I tried to keep giving it over and over again. And the symbol for this is a giant W for work. All right. So these right here are true for all my classes. All right, elastic is only for my honors classes. So in this intro, I did not want to do two totally different intro ones, but just keep a heads up on that. That doesn't mean that you don't have to be unaware of elastic. It's just we're not going to do any math with it. There are several other types of energy out there. You did some from chemistry, like chemical energy, chem. So, when you eat your breakfast and you get the energy in your system, then that is chemical potential energy. So that's basically when bonds are broken or formed, and that has to do with chemistry. But again, we're not going to equate that in physics, and it's not really going to show up very often. So, you took chemistry, you know that stuff. All right. Now, how are we going to actually analyze these energies and these transfers of energies? Well, let's talk about that. So, this is all the basic stuff. Oh, one last thing before I go on. Little side note here. The units of energy are joules, or capital J for joules, and those are the units of energy that we use. So, and we'll talk about how they break up to other stuff, but that's the fundamental units of energy. So let's talk about how it happens with energy. And there's one thing you need to understand, and this is a universal law, and that is energy can never be created or destroyed. And this is what's referred to as the conservation of energy. So when someone says, "Hey, turn those lights off. We don't want to waste energy. You don't want to lose energy. You're wasting energy." That's not actually possible. You can, as humans, though, we can only have energy in so many usable forms. So, for example, when you look at a dam and the water's rushing over the dam, which moves the turbines, which then makes electricity, and the electrons go back and forth. Well, that's energy. We're like, yes, I can use that. But once it gets into a form like heat, we're not very good at using heat or capturing heat. And so when you leave your lights on, you'll notice they get rather toasty. If you've ever tried to unscrew a light bulb while it's on, you're like, the burning sensation. And my dad used to always lick his fingers. It was kind of creepy, but that has to do with, again, energy and chemistry. So, point is, it's kind of lost. It's vapor. It's going off into the atmosphere, and the room gets warmer. And then I'm a parent, so I'll be like, "Hey, close the door. You're heating the outside." Well, yeah, that's the way it always works. So we always try and insulate and keep the heat in, because once energy gets into the form of heat, we're very bad at using that as humans. So it's not that it disappears, but disappears in a usable form. So fundamentally, energy cannot be created or destroyed. Now, I know some of you smart Alex out there are going to say, well, what about this? And so I just thought I'd talk about this. E equals mc squared. It's one of the most famous equations in all of science, and yet basically no one knows what it means. And this literally says energy equals mass times the speed of light squared. And what that is it's actually an equation that in a way kind of breaks this energy is created or served. But what it is it shows that mass is actually related to energy, and this is how stars work. And when they change the amount of mass and things like that, they'll take energy to make mass, and then they'll take mass to make energy and things like that. And so again, energy is created or destroyed, can never be created or destroyed. And if you remember from chemistry, they're saying, well, that's the same thing with mass. Mass cannot be created or destroyed, and those are both true statements. But there's also this other true statement that mass can be converted to energy. Just a fun sidebar because I know some of you smart Alex out there are gonna be like, "Oh, what about this?" And no, I'm well aware of this, but don't worry, we're not gonna play with this bad boy. All right, we're just gonna work with these forms of energies up here. All right. So, how do we actually view this? Well, I'm going to talk about that in our next video because I've been babbling long enough. Okay, so I'll talk about the different ways in which we view and pay attention and keep track of energies next time. So, hope this was informative, and I'll see you on the flip side.